we've got the integral of the square of a function is equal to the square of the integral of a function. So we'll start off and we'll let f of x be the square root of some other thing, and that some other thing can be y. And that means then our equation is going to be the integral of y is equal to the square of the integral of the square root of x. So next step, what we'll do, we'll differentiate. So the left-hand side will just be y, nice and simple. And the right-hand side, we'll use the chain rule. So we're going to have two lots of the integral of the square root of y. And then by differentiating inside of our square bracket there, what we'll get is root of y. We can now divide both sides by root of y. But that means then that we're going to have a solution, y equals 0. Nice trivial solution there. But on the left-hand side now, we'll get y over square root of y. So that is the square root of y. Is equal then to 2 multiplied by the integral of the square root of y with respect to x. To do anything here then, what we're going to do again is differentiate. So the left-hand side, we will get 1/2 multiplied by 1 on root y multiplied by dy dx. And the right-hand side, we'll get two lots of root y. Now, we'll try and separate the variables. So we'll bring the root y to the left, and the half can go to the right. So what we're going to get is dy on y is equal to 4 dx. Integrating both sides. Left-hand side, we'll have the log of y. Right-hand side, we'll have 4x plus a c. So altogether, y is going to be equal to e to the 4x plus c, but that plus c, we can change into another constant out the front, so e to the 4x. And then, if we remember our very first step, we need to square root this whole thing. So f of x is going to be equal to a times e to the 2x. A here I know is different than this a, but that's all completely fine. It's just a constant at the end. And also, we'll have to square our y equals 0, and that will give us f of x equals 0. But that's kind of sorted up in the fact that we just have a constant here.